So in this problem, instead of finding the electric force, we're going to find the electric field. And remember, the electric field, E is equal to K, the magnitude is Q, over R squared. And here we just have one charge, so we're just finding what direction is the field felt at a certain point due to a charge Q at a distance R away. So in this case, we've got Q1, which is plus 5 microcoulombs. Q2 is plus 5 microcoulombs. And Q3 is minus 5 microcoulombs. And again, we have equilateral triangle. They're 2.75 centimeters on each side. And we want to find what's the magnitude of the electric field at a point that's halfway between Q1 and Q2. So along the line right about there. So we're going to do the same steps we do for electric force. So first we're going to draw the field vectors on. So let me go to a different color. So electric field comes out of a positive charge radially. So Q1 is positive. So E1 is just going to be an arrow going along the line between Q1 and Q2. E2, the electric field due to 2 at this point that I've marked with the X, is going to be away because again it goes out of a positive charge. And so E1 and E2 are opposite to each other in direction. And E3 goes into a negative charge, so it goes from that point with the X, black X, to point Q3. So there's E3. So I'm going to do the same thing that I did before. I'm going to find the magnitude, break it into components, add it together. All right, so what's E1? E1 is equal to KQ1 over R1. E2 is KQ2 over R2. And again, for these charges, we're going to take just the absolute value of them. And E3 is KQ3 over R3. And those R should all be squared. So R1 is the distance from my black X here to charge 1. So this is R1. R2 is the distance from the black X to charge 2, so R2. So each R1 and R2 are each going to be half of the side. So R1 is equal to R2, which is equal to half of 2.75 centimeters. And if we look, Q1 is also equal to Q2. So what that means is, if I look at my equation here, KQ over R squared is going to be the same value for E1 and E2. So those two vectors are equal to each other. And if we look at the picture, they're opposite in direction. So those are just going to cancel out. So they're equal and opposite. So they cancel. And so we don't even have to bother doing any calculations. All right, how about E3? Well, E3 doesn't have any vector opposite to it to cancel it, so we're going to have to do the calculation. So let's plug in our numbers. So K is 9 times 10 to the 9. Q3 is negative 5 microcoulombs, and remember I'm taking the magnitude. So I'm going to throw away the minus sign. And micro is 10 to the minus 6, so I'm going to put 5 times 10 to the minus 6. And then we have the question, what is that distance between my X, where I'm finding the electric field, and where charge 3 is? So it's going to be this distance here, diagonally across the triangle. So let me just sketch out just that bottom part that I have there. All right, so if I look here, I've got that hypotenuse there. That's R3 that I'm trying to find. This is a right angle triangle. So I guess this isn't actually a hypotenuse, is it? This side here at the bottom, that's the hypotenuse. So I know what the bottom side is. That's D, right? Which is 2.75 centimeters. And this side here goes from Q1 to the halfway point. So that's going to be half of D. So what I know is by Pythagoras' rule, the hypotenuse, which is the D, is going to be equal to the sum of the squares of the two sides and square root. So I know D squared is equal to d over 2 squared plus r3 squared. It's just Pythagoras. So if I want to find r3 squared, which is what I want for my denominator there, it's just going to be equal to, I need to take that d over 2 squared to the other side. Okay, so that's d squared. If I square the other term, I get d squared over 2 squared, so d squared over 4. So that's 3/4 of d squared, where d is my 2.75 centimeter side of the triangle, or remember, I'm going to put that in meters, 0.0275 meters. All right, so let's put that in. So E3 is equal to k, 9 times 10 to the 9, times 5 times 10 to the minus 6. And in the bottom here, I'm going to have 3/4 of d squared. So I'm going to have 3/4 of 0.0275 squared. I get 7.93 times 10 to the 7. And the units for electric field are newtons per coulomb, or we'll learn in the next chapter could also be volts per meter. All right, so that's the size of the electric field. What's the direction? Well, we just have this one vector here, and we know that angle's 30, that angle's 60 for an equilateral triangle. So let's see, that's 90 plus 60, or 180 minus 30. So it's 150 degrees from the plus x direction. And this question didn't actually ask for the direction, it only asked for the magnitude. So really, I only needed that number.